All right, so this tutorial will be fairly short on my content. I'm not going to go into how to actually program in Python at all. I'm going to give you tips about how to use Python effectively on blue waters. So, as I'm sure everyone knows, to get the actual supported Python on blue waters, you need the BWPy module, which I manage, and so you just do a module load BWPy. These are the interpreters that I have made available. If you've just typed Python, you might not have actually seen them, but chances are you have. So CPython 2.7 is currently the default. It's also aliased as Python 2. I've also got 3.3, 3.4, and 3.5 installed, and the default of that is Python 3. Nobody's actually been using them, but I also have PyPy and PyPy 3. Those don't have as good of NumPy support. It's not quite good enough to have SciPy support. So not everyone can use it, but it has a just-in-time compiler. So some of the people that I've talked to last week at the Cray user group said that they had tried PyPy on their systems and they got quite a decent speed up, like at least 10 times. So good to keep in mind if you don't need all of the features of NumPy. So there's a number of submodules. As you know, if you try to run an MPI application on a login node, it will fail. So I need to be able to support users who are using Python on both the login nodes and the compute nodes. So the BWPy MPI submodule is used to layer on top of the BWPy module, only including the things that are MPI enabled. Then there's two new modules, which I don't know if anyone's using yet, but I haven't made any announcements really. Actually, I think there might have been an email about this. But since so many people use NumPy and these libraries that use BLAS, I made two different BLAS defaults, BLAS versions, one using the OpenMP libsci and one with the accelerated OpenACC libsci BLAS. So those might be worth looking into since the CPython interpreters all have a global interpreter lock, you can't really do threading all that easily. So you might want to look into a parallel BLAS. Then I also have a couple TensorFlow modules because those come out way faster than I release BWPy. So nearly all of you are using Python 2.7 still. And there's actually a fairly decent distribution across login and compute nodes. People do use it in both contexts. The usage on mom nodes is a bit higher than I had expected it to be, so make sure that you're actually using app run when you need to. But if you're using it to actually launch jobs from Python itself, go right ahead. We've had about 270,000 Python invocations since January 13th when I started recording this data. So you do use it at a fairly decent rate. So yeah. So to make your Python scripts a little bit more portable, one thing you can do is rather than using the path to Python like userbin Python, you can use userbin env, and then it will grab the Python that's currently in the environment. Then you can make your script executable. So that way, if you run it on a different system or something like that, it will work. So, well, assuming that you have all the modules available and all that, but you'll know where to find Python anyway. And really, guys, you've got to start moving to Python 3 because Python 2.7 is ending its life in a couple years. They announced that in 2020, they're going to stop patching Python 2. So that's a little less than 3 years away. And I know how long it takes to refactor codes and stuff like that. So I'd get working on it because while we might still have it installed, it won't be getting security patches and stuff like that. So it's like, yeah. So, and there's a website where you can see the countdown timer. So, and here's a little bit of statistics on how BWP is being used. This is by user, so these are unique user counts. Out of 131 users, almost 100 are using NumPy. So there are a few people who might be able to get by using PyPy and get some performance out of that. There were 663 different types of modules being loaded, which is pretty impressive. And yeah, PyPy is cool. Looking at the job wall times that people are using, there's a lot of jobs which are very, very short. We're talking, the largest bucket here is less than 15 minutes. So that can be fairly hard on our scheduler and stuff like that. It doesn't really like it too much. And it'd be nice if you could roll things up into a single job. It would make the system work a little better. And as far as executions per job goes, some people are running Python lots and lots of times. It might be fine to do this in a bash script. We're iterating with a bash script and executing Python a bunch of times on your laptop. But on Blue Waters, it takes 14, 15 seconds for Blue Waters for Python to start up. Yes?
I'm curious, on your previous slide, if you're only looking at jobs that exit successfully from that?
Yes, these are jobs that exit successfully, yes. So while it might be fine to do a bash for loop and iterate with Python on your local computer, since Lustre is such a slow file system as far as IOPS goes, it's really best for both the previous case and this case as well, to create a pipeline script where you launch Python once and it goes through and iterates things in a pipeline, only needing to load Python up once. So that will get things running faster. And I was talking to somebody yesterday. They said they had a script that they're going to launch Python 10,000 times. So you figure a few seconds per iteration, and the load of that on the file system, that can add up. So be nice to the file system, guys. So. And just a little bit of statistics on the job sizes as far as how wide they are. Most of you guys are doing single load jobs, which is fine. The MPI for Pi wasn't actually as high as I thought it might be used, but I know a lot of people do visualization and analysis and stuff like that with Python as a secondary tool. So, all right, so that's about what I could come up with as far as trying to use Python better. There's some things that I'm going to be working on as far as trying to get Python launching faster and reducing the burden on the metadata server, and so that things don't hammer at the file system. So, but that's still a work in progress. So for now, it would be helpful if people, and I would say better practice to try to do it in some sort of pipeline. So, any questions?
All right, thank you. I think it would make sense not to ask questions, but to ask, do you have any concerns, recommendations, or...
So you mentioned you wanted people to start using Python 3 more. Are you planning to change the alias to Python to be Python 3 instead of 2?
That's a pretty major change. As far as me doing it, as far as the configuration goes, it's a really easy thing, but I don't want to have a whole bunch of tickets coming in. Oh, why is this not working anymore? So, because people call user bin in Python rather than specifying Python 2 or 3. So, when they're writing code that actually isn't agnostic to Python versions, it's a bit of a bug, but yeah. Mm-hmm. Yeah. So that's a good thing to mention is if you are doing stuff that can use Python 2 or 3, just call Python. If you can only need 2 or only need 3, use those aliases.
Have you been working with Ufang with this Python MPI cast?
No, I haven't. I'm familiar with it though. What I am planning to do is something similar to Shifter, where an image gets mounted up on the nodes, and that means that all of the file system information is on the local memory of the compute nodes. It reads it as an ext3 image or something like that. So that reduces things by a significant amount, as the Shifter teams have found. Anyone else?